Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Now, parallel polarization or vertical polarized wave. Now I am considering a conducting or reflecting surface along the x-axis, that x equals to 0 plane, and incidence plane is along the z-axis. Now the wave is incidenting with an angle theta 1 and reflecting with an angle of theta r, and this is our transmitting angle theta 2. If the electric field vector E or electric field intensity is in parallel with the incident plane, we can say, and which is at an angle of 90 degrees or perpendicular to the conducting surface. So, with respect to incident plane, the electric field intensity E is in parallel, so parallel polarization, and with respect to conducting surface, E is perpendicular, so vertical polarization wave or vertical polarized. Now, applying the boundary conditions, Et by Ei equals to here 1 minus Er by Ei cos theta 1 divided by cos theta 2. Since Ei minus Er of cos theta 1 equals to Et cos theta 2. Now we have Er square by Ei square equals to 1 minus square root of epsilon 2 divided by square root of epsilon 1 Et square Ei square cos theta 2 divided by cos theta 1. Er square divided by Ei square equals to 1 minus square root of epsilon 2 divided by square root of epsilon 1. So Et by Ei equals to 1 minus Er by Ei whole square and cos theta 1 by cos theta 2 whole square, then cos theta 2 by cos theta 1. So square gets cancelled along with this. Then you can expand this 1 minus Er by Ei square. Now I'm taking this towards this and this one is towards here. Then this will be epsilon 2 by square root of epsilon 1 cos theta 1 divided by cos theta 2 1 minus Er by Ei whole square. This one looks like a square minus b square, then a plus b into a minus b, that is 1 plus Er by Ei multiplied by 1 minus Er by Ei, that equals to square root of epsilon 2 divided by square root of epsilon 1 cos theta 1 divided by cos theta 2. This is again 1 minus Er by Ei square. Now this term and square term, so single term remains. Then this one 1 plus Er by Ei equals to, now I am multiplying this, then square root of epsilon 2 divided by square root of epsilon 1 cos theta 1 divided by cos theta 2 minus Er by Ei square root of epsilon 2 divided by square root of epsilon 1 cos theta 1 divided by cos theta 2. Now I am taking Er terms to one side, that is Er by Ei, and taking Er by Ei common. So these are the two terms. Then 1 plus epsilon square root of epsilon 2 square root of epsilon 1 cos theta 1 divided by cos theta 2, that equals to, I am taking this one on other side, then square root of epsilon 2 divided by square root of epsilon 1 cos theta 1 divided by cos theta 2 minus 1. Now solving this, that you are going to get Er by Ei of square root of epsilon 1 cos theta 2 plus square root of epsilon 2 cos theta 1 divided by square root of epsilon 1 cos theta 2 equals to square root of epsilon 2 cos theta 1 minus square root of epsilon 1 cos theta 2 divided by square root of epsilon 1 cos theta 2. Now cos theta 2 gets cancelled. Then you are going to get the reflection coefficient TR equals to ER by EI, that equals to this term divided by this term, that is nothing but square root of epsilon 2 cos theta 1 minus square root of epsilon 1 cos theta 2 divided by square root of epsilon 1 cos theta 2 plus square root of epsilon 2 cos theta 1. So this is our reflection coefficient in case of parallel polarization. This equation can be modified by using Snell's law, that is sine theta 1 divided by sine theta 2 equals to square root of epsilon 2 divided by epsilon 1, from which we can write sine theta 2 equals to square root of epsilon 1 divided by epsilon 2 sine theta 1. Then 1 minus sine square theta 2 equals to 1 minus epsilon 1 divided by epsilon 2 sine square theta 1. Since sine theta 2 is nothing but this is nothing but our cos square theta 2, that equals to 1 minus epsilon 1 divided by epsilon 2 sine square theta 1. From this, cos theta 2 equals to square root of 1 minus epsilon 1 divided by epsilon 2 sine square theta 1. Now substituting this value in the equation, you are going to get TR equals to square root of epsilon 2 cos theta 1 minus square root of epsilon 1 of square root of 1 minus epsilon 1 by epsilon 2 sine square theta 1 divided by square root of epsilon 2 cos theta 1 plus square root of epsilon 1 of square root of 1 minus epsilon 1 divided by epsilon 2 sine square theta 1. Now, after simplification, you are going to get TR, that is reflection coefficient, equals to epsilon 2 divided by epsilon 1 cos theta 1 minus square root of epsilon 2 divided by epsilon 1 minus sine square theta 1 divided by epsilon 2 divided by epsilon 1 cos theta 1 plus square root of epsilon 2 divided by epsilon 1 minus sine square theta 1. This is our modified equation for reflection coefficient in terms of incident angle. BREWSTER angle. Let the reflection coefficient TR equals to 0, which means there is no reflecting wave. When TR equals to 0, TR bar TR equals to 0, which means TR equals to 0. And we have the formula we derived just now. From that, numerator epsilon 2 by epsilon 1 cos theta 1 minus square root of epsilon 2 by epsilon 1 minus sine square theta 1 under square root equals to 0. Epsilon 2 divided by epsilon 1 cos theta 1 whole square equals to epsilon 2 by epsilon 1 minus sine square theta 1. And this you can write epsilon 2 by epsilon 1 whole square 1 minus sine square theta 1. That equals to epsilon 2 by epsilon 1 minus sine square theta 1. Epsilon 2 by epsilon 1 whole square minus epsilon 2 by epsilon 1 sine square theta 1 is equals to, this is also whole square, right? Equals to epsilon 2 by epsilon 1 minus sine square theta 1. Take the sign terms on one side. Sine square theta 1 minus epsilon 2 divided by epsilon 1 square sine square theta 1 equals to epsilon 2 by epsilon 1 minus epsilon 2 by epsilon 1 whole square. Now taking the LCMs on both sides, then epsilon 1 square sine square theta 1 minus epsilon 2 square sine square theta 1 divided by epsilon 1 square equals to epsilon 1 square is common, then this is epsilon 1, epsilon 2 minus epsilon 2 square. Take the common, sine square theta 1 of epsilon 1 square minus epsilon 2 square equals to, from this 2 we can take epsilon 2 common, then epsilon 1 minus epsilon 2 sine square theta 1 equals to epsilon 2 epsilon 1 minus epsilon 2 divided by, this is a square minus b square, that is epsilon 1 minus epsilon 2. Similarly, epsilon 1 plus epsilon 2 gets cancelled. Then finally, after simplification, we are going to get sine square theta 1 equals to epsilon 2 divided by epsilon 1 plus epsilon 2. Now, from this you can write sine square theta 1 is nothing but 1 minus cos square theta 1 equals to epsilon 2 divided by epsilon 1 plus epsilon 2, from which cos square theta 1 equals to 1 minus epsilon 2 divided by epsilon 1 plus epsilon 2. Now taking the LCM, then you are going to get epsilon 1 plus epsilon 2, epsilon 1 plus epsilon 2 minus epsilon 2. Epsilon 2 gets cancelled, then cos square theta 1 equals to epsilon 1 divided by epsilon 1 plus epsilon 2. Try to find out tan square theta equals to sin square theta divided by tan square theta 1 1 tan square theta 1, that equals to epsilon 2 by epsilon 1 plus epsilon 2 divided by epsilon 1 by epsilon 1 plus epsilon 2. Now these two terms gets cancelled. You are going to get finally, that is epsilon 2 by epsilon 1 tan square theta 1, and from which tan theta 1 equals to square root of epsilon 2 by epsilon 1. Theta 1 equals to tan inverse of square root of epsilon 2 by epsilon 1. Angle theta 1 is the angle of incidence at which there is no reflection at all, when the incident wave is parallelly polarized or vertically polarized. Then the theta 1 is termed as BREWSTER angle. Considering one problem with the parallel polarized, first medium is air where epsilon r equals to 1, and the second medium, that is after the conducting or reflecting surface, is glass with er equals to 10. Then I need to find out BREWSTER angle theta 1. We know that equals to tan inverse of square root of epsilon 2 divided by epsilon 1. Then epsilon 1 is the permittivity of air, which equals to er E naught. Er is 1, so this is our E naught, and epsilon 2 is permittivity of the glass, that equals to Er of the glass, and E naught, that equals to 10 epsilon naught. Then BREWSTER angle theta 1 equals to tan inverse of square root of 10 epsilon naught divided by epsilon naught, or tan inverse of 10, 72.4516 degrees. If a wave traveling in air medium incidence reflecting surface of glass with 72.4516 degrees, then there is no reflection.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.